All right, you guys, I'm going to talk a little bit about multiplying binomials and just kind of show you the basics of it and why. I'll throw a little y on there. We have something called the order of operations, which always says that multiplication always happens before addition. All right, so this kind of gives us a common math language and allows people to come up with the same answers when given a problem. So we've set these rules. I imagine originally they were somewhat arbitrary, but now they're set in stone. And I want to show you how this can sort of describe the process that we use to distribute when we always consider multiplication has preference over addition, always comes first. I'm going to start that with just like I don't know, maybe 6 times 5, all right, which we know is 30. 6 times 5 is definitely 30. And this would be the same even if I had 6 times another version of 5, let's say 3 plus 2. All right. So as long as I do all my multiplications before I do my additions, I'll always get my same answer. And we've shown this as a distributive property. All right. So I can go 6 times 3, which is 18. As if I distribute that 6 to that 2, 6 times 2 is 12, and once again I get 30. Well, with binomials, we usually have 2 separate terms, right, in parentheses. So let's change that 6 to, I don't know, let's go 4 plus 2. And then we'll change the 3 plus, well, we'll leave it 3 plus 2. And we'll show you this, that as long as we consider that multiplication has priority over addition, we're still going to get 30. But this time, there's 2 terms in both. So if I distribute that 4, I get a 12, right? If I distribute that 4 here, I get an 8, right? If I distribute that 2 twice, I get 6 and 4. And if I just add these, I don't know, that's 20, and this is 10, I once again gets 30. All right. We take this and we use this to solve situations or find answers for problems that have variables in it. Because very often we're going to take 6 and make it 4 plus 2. But what we may see is a problem like, well, let's do the first one on your page 12. I'm going to bring it over here. All right. See if I can zoom in a little bit here. You know what? Let's go to 8 on page 12. There's 8. And what we do is we take everything in the first, this x, and I multiply by everything over there, which gives me x squared. That's x times x. And then it looks like I get a negative 5x. Then we take the other term in here, a negative 4, and I distribute it through, which gives me negative 4x plus 20. So when you do this, you get this, well, let's combine like terms. Let's finish up. We get x squared minus those 2 x's are like terms, so minus 9x plus 20, and we circle that as an answer. All right. So I want to show you. The first thing I did is I distributed this x to there, and those happens to be the first terms in each one. First term here, so you can put an f. Then I took this x here and I distributed it to that negative 5, and those, if you consider this a solid line, that's on the left outer side and the right outer side. Then I took this negative 4, I distributed it to the x, and well, if you consider it a straight line, those are on the inners. And then I took the negative 4 and I multiplied by negative 5, which happens to be the last term in each binomial. And that gets us that little thing that we call FOIL, which works to help us distribute, right? F-O-I-L, distribute binomials to each other. Just really quick, I'm going to come down here and finish this up on page 12 because there's something else down here. So when you see this, let's get one. I'm going to kind of scoot back out. I'm going to set this guy up. And we just got through a lot of these. If you finished, I'm going to readjust. Hopefully this will show up all right. If you finished all the other pages, you just got done doing stuff like this. So this says, hey, give me a line parallel to this right here. Let's scoot it a little bit here. I need to get a better work environment. I have been traveling around. I'm not at home and kind of making use with my environment. So if you look at it, I'll try to do it from down here. 4x plus 2y equals 8. If it's parallel, what I need to know is I need to know the slopes, because 2 equations with the same slope right, are parallel. So I'm going to go ahead and I'm going to subtract 4x, which gives me 2y equals negative 4x plus 8. I'm going to divide by 2, which gives me y equals negative 2x plus 4. But I just want a piece of that. I only want that slope. And I can see the slope of this line, and I'm going to write it as a fraction, as negative 2 over 1. That means any line parallel also has a slope of negative 2 over 1. So if you come over here, you know a point, and you know the slope is negative 2, and use that right there, that point and that slope, to figure out the equation of the line. And you do this the same as we did problems on 10 and writing equations from 2 points once we figured out the slope. So 10 and 11, this at this point is just like those problems where you either had 2 known points or a point in the known slope. So good luck. Page 12, I'm going to try to get page 13, maybe even 14 up today. There's a lot of little different aspects of quadratics we have to talk about, but hope you're enjoying your summer. Keep up to date.